Okay, and we will be looking at problem 2 now. So this one is this square figure here. And we will first off write, because this is a Coulomb's law problem, we will write here F equals K, and then Q1, Q2, this is all over R squared. And now we can also list up here what Q1, Q2, Q3, and Q4 are. And it says here that Q1 is equal to negative Q2, so that's going to be 300. This is a nanocoulomb, so to convert that back to regular, we will just do 10 to the negative 9, and then this is going to be negative 300 times 10 to the negative 9, and then 3 and 4 is 245 times 10 to the negative 9, and then 245 times 10 to the negative 9. It wants us to list all of how all the charges interact with particle 3. So our next step is the forces of 3 with 1, the forces of 3 with 2, and the forces of 3 with 4. And using the Coulomb's law here, we will know that each of these is going to be 8.99 times 10 to the negative 9. Or, no, it would just be 10 times 10 to the 9. Yeah, 8.99 times 10 to the 9. And then we would have our Q1s, and let's see, this is going to be 3 versus 1. So this is going to be 245 times 10 to the negative 9 times 300 times 10 to the negative 9. And oops, I almost forgot to say R equals 4.5 centimeters, which is 0.045 meter. And of course, it's going to be 0.045 squared. Same thing here. This is 3.2. So this one's going to be 245 times 10 negative 9, 300 times 10 negative 9, except for our R here is not flat out given. We need to find the distance here. Why not? We need to find that distance. And so A times A, if this is a perfect square here, then what we have here is just going to be let's go to the brush tool. It's going to be A square root 2. And because A equals 4.5 centimeters, then we wrote that as R. R equals 4.5 centimeters. Convert to meters, 0.045. and then add the square root 2. This is going to be what we put here. And then 3, 4 is going to be 245 times 10 to the 9, 245 times 10, negative 9, and then 0.045 squared. We are going to get a 0.36326. And here we get 0.163, and we get 0.266. So now we have to list what the x's and y's are going to be that is acting on the particle 3. So right here, we know that we have a y instantly. We have nothing on x for, let's just say, let's list these out. This is going to be F31, F32, and then F34. So for this, we've got nothing acting against in the x direction. It's just along y. And particle 1 is positive, and particle 3 is also positive. So it's not going to be attracted, it's going to be repelled, making this a negative y. So now we have negative 0.326. And for 3, 2, this is acting along an axis that is not completely x or completely y. It is somewhere in between. We know that theta here has got to be 45 degrees because this is a perfect square. So what we could do is we could take the value here. See, 2 is negative. So this is going to be an attraction. And this was going to be then a positive sine value and cosine value for x and y. So if we do, for here, a sine of 45 on 0.163, let's see. So yeah, 0.163 sine of 45, we're getting 0.115, and same thing with cosine. And it's getting pulled in the positive x and positive y direction. And then for 3, 4, this is completely in the x direction. And particle 4 is negative, so particle 3 is going to be attracted to it, so it's going to be a positive x value of 0.2660 y value. And now we just add these up. And so for x, we get 0.115 plus 0.266. Yes, this is going to give us a 0.3818, so rounding up 0.0382. And for this one, we have negative 326 plus a positive 115, which is going to give us negative 0.2109, rounds up to 0.211. And this is our y value and x value answers.